In this lesson, you will place mechanical equipment, including 2 water source heat pumps and a condensing boiler, on level 3 of the building model. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 01. Then zoom in to the right side of the shorter building wing. Then, from the Home tab's Mechanical panel, click Mechanical Equipment. Then, click the Change Element Type drop-down, and from under WSHP Horizontal High Efficiency 2 to 6 tons Left Return Right Discharge Type, select 6 ton. Then press the spacebar to rotate it and place it in the corridor as shown. Then click the Annotate tab, and from the Dimension panel, click Aligned. Then zoom in to the heat pump and the wall, and click the corridor wall face, and then the top edge of the heat pump, and then place the dimension as shown. Then click Modify and select the heat pump, and then click in the dimension value and type 2 and enter. Then place another heat pump to the left of the one you just placed as shown. Then click Modify, and while pressing Ctrl, select the 2 heat pumps. Then go to their instance properties, and in the instance properties dialog, under Constraints, for offset, type 9 feet. Then under Mechanical, change the water flow value to 12 GPM. Then click OK and clear the selection. Click Mechanical Equipment again, click the Change Element Type drop-down, and under Condensing Boiler, select 500 MBH. Then press the spacebar 3 times to rotate the component, and then place it in the mechanical room above and to the left of the base mounted pump as shown. Then click Modify and close the file without saving the changes, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will create the return and supply piping systems, and you will use the system browser to review and confirm the systems. Click the menu browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 02. Zoom in to the right side of the shorter wing of the building, and in the system browser, right-click the title and move to View and select Piping. Then expand the Unassigned folder, and then expand the default Hydronic Supply 1 and the default Hydronic Return 1 systems to view the mechanical equipment placed in the building. It is important to note here that all mechanical equipment in the project should be assigned to a system other than a default system. Equipment that remains in a default system is included in heating and cooling loads calculations. Therefore, leaving a large number of components in a default system can hinder performance and prevent accurate calculations for the systems where they should have been assigned. In the drawing area, while pressing Ctrl, select the 2 heat pumps. Then, from the Create Systems panel, click Hydronic Return. Then, from the System Tools panel, click Edit System. On the options bar, for system name, type CHWR for chilled water return. Then, from the Edit Piping System panel, click Select Equipment and select the boiler. Then, click Finish Editing System. Then, select one of the heat pumps. Then, from the Create Systems panel, click Hydronic Supply. Then, click Edit System and change the system name to CHWS for chilled water supply, and with the Add to System tool active, select the second heat pump. Then, in the project browser, under HVAC Design, Floor Plans, double-click Roof HVAC Plan Design. Then, zoom in to the right side of the shorter wing of the building and select Add to System and click on the cooling tower. In the Select Connector dialog, with the Connector 1 selected, click OK. Then, close the roof plan view. Then, click Select Equipment and select the boiler. You're selecting the boiler as equipment for supply to the heat pumps. The boiler is the only equipment that has connectors with compatible system types: hydronic supply and hydronic return. In heating mode, the boiler supplies heated water to the system and bypasses the cooling tower. In cooling mode, the cooling tower provides cooled water to the system. The water returns through the boiler into the cooling tower by way of the heat pumps. Click Finish Editing System. Note that in the system browser, the new system named CHWS is now listed under Hydronic Supply, Condensing Boiler. Right-click the Hydronic Supply category and click Expand All. Using the same method, expand the Hydronic Return System category. You can now view the system's hierarchy. CHWR and CHWS logically connect the boiler, the parent, with the WSHPs, the children. Right-click CHWS and click Select. When you do, the hydronic supply system highlights in red, indicating the logical connection. In the system browser, in addition to viewing several parameters, including the flow rate and the size of the component, you can also select the columns you want to display. Right-click the Systems column heading and click Column Settings. Then, in the Column Settings dialog, under Columns, expand Piping and select Fluid Type and Fluid Temperature and click OK. For one of the WSHPs in the CHWS system, right-click the flow value and click Properties. Then change the water flow value to 18 GPM and click OK. Then close the file without saving any changes, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will create the physical connections in the pipe system automatically using the Generate Layout tool. You will also manually modify the layout path as required. Click the menu browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 03. Select one of the heat pumps as shown. Then, from the Layout panel, click Generate Layout. In the Select a System dialog, select CHWR and click OK. On the options bar, for solution type, select perimeter. For inset, type 1 foot 6 inches. And zoom in to the right side of the short wing and click Next Solution until 4 of 5 is selected. Then click Finish Layout. The current view is Level 3 HVAC plan design. Let's add the Level 1 heat pumps to the return system. Select the heat pump on the left. Then click the Piping Systems tab, and on the System Tools panel, make sure that CHWR is selected under System Selector and click Edit System. Then open the view Level 1 HVAC plan design. Then zoom to fit and click Add to System and draw a selection window to select the 6 heat pumps. When you do, on the options bar, the number of elements is now 8, and logically, the Level 1 heat pumps are now connected to the chilled water return system. Close the Level 1 plan view and click Finish Editing System. Next, you'll physically close the CHWR loop, which propagates flow throughout the system. Zoom into the piping that comes from the floor below. From the View tab, click Thin Lines for a better view, and select the bottom piece of the horizontal pipe. Then extend the pipe to the left and connect it to the existing pipe. Next, we'll manually modify piping in layout mode. Zoom out and select the heat pump after clearing the selection. And from the Layout panel drop-down, select Generate Layout. From the Select a System dialog, select CHWS and click OK. On the options bar, for Inset, type 1 foot 6 inches and click Settings. For Main Offset, type 9 feet 6 inches. Then select Branch and change the offset to 9 feet 6 inches as well. Then click OK. Then from the Generate Layout tab, click Remove and select the boiler to remove it from the Layout Path solution. Then click the supply pipe from the cooling tower above. In a later lesson, you will connect the boiler to parallel connected base-mounted pumps. Click Modify and zoom in and select the right vertical green sketch line as shown. Then, while holding Control, select the vertical sketch line just above it. Then, click and drag the 4-way arrow control to the left, just to the right of the double door in the underlay. Then, select the short vertical path line connecting the right heat pump and drag it to the right to align it with the sketch lines you moved. Then, zoom out so you can see the entire layout and click Finish Layout. Then, close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will manually lay out piping to create a closed loop system. Click the menu browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 04. In the project browser, under HVAC Design 3D Views, double-click 3D HVAC Building. Then click the View tab, and from the Windows panel, click Tile Windows. Then adjust the view in both windows to see the connections on the boiler. Then, in the 3D view, draw a selection window around the elbow fitting and the small piece of pipe connecting into the boiler return connector. Then, click Delete. Then, in the plan view, select the section of piping as shown and move it up 4 inches. Then, clear the selection, and in the 3D view, select the boiler. Then, from the Layout panel, click Connect Into. In the Select Connector dialog, select Connector 2 and click OK. Then, select the Return Pipe Riser. Next, we'll connect the primary base-mounted pump to the boiler. In the plan view, select the boiler. Then, right-click the top grip that represents the supply connector and click Draw Pipe. On the element panel, click the Change Element Type drop-down and select Standard under Pipe Types. Then, press the spacebar to acquire offset and pipe diameter values from the connector. Then, move the cursor to the right and type 2 feet and press Enter. Then, on the options bar for offset, enter 1 foot 7 inches. Then, add another 2-foot section of pipe to the right. Then, move the cursor down and click just before the midway point on the primary base-mounted pump. Then, press Escape twice and notice in the 3D view that the specified offset dropped the horizontal run down. In the plan view, select the primary base-mounted pump, which is the top one, and from the Layout panel drop-down, select Connect Into. In the Select Connector dialog, select Connector 2 and click OK. Then, select the last segment of pipe you drew. Then, zoom in to the elbow fitting and select it and click the bottom plus symbol to upgrade it from an elbow to a T. Then select the T fitting and right-click the bottom connector and click Draw Pipe. Then zoom out until you can see the base-mounted pump and move the cursor down until the alignment indicates that it's at the intersection of the base-mounted pump and click. Then move the cursor to the right, and when the connector point displays, click to connect to the pump. Then press Escape. Then, if necessary, zoom out in the 3D view to see the new connections. And back in the plan view, select the primary base-mounted pump. Then, right-click the discharge connector and click Draw Pipe. On the options bar for offset, enter 4 feet. Then move the cursor down until it joins the connector point on the secondary base-mounted pump and click to create the pipe. Then press Escape, and in the 3D view, zoom into the elbow fitting on the left or secondary base-mounted pump, and using the method previously learned, upgrade the fitting to a T connector. Then, back in the plan view, select the T connector, right-click its bottom control, and click Draw Pipe. Then, move the cursor straight down and enter 1 foot. Then, on the options bar, for offset, enter 9 feet 6 inches. Then, zoom out and move the cursor down and click the point at the intersection and vertical with the pipe shown. Then, click Modify. Next, you will physically connect the cooling tower piping to propagate flow. In the 3D view, select the cooling tower. Then, click the Modify tab, and from the Edit panel, click the Extend drop-down and select Trim Extend Multiple Elements. Then, in the plan view, select the supply pipe, then the upper pipe going to the cooling tower, which is the inlet, and then the lower pipe, the outlet. Press Escape. Then, close the project file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will add valves to model the piping for 2 modes, cooling mode and heating mode. You will add a bypass valve to stop the flow and direct it to the cooling tower in the cooling mode. When the valve is open, the water bypasses the cooling tower and is heated by the boiler. You will also add shutoff valves to control the flow to and from the cooling tower. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 05. Let's place a bypass valve to control flow to the cooling tower. Zoom in to the shorter wing of the building and click the section of pipe between the supply in and supply out pipes to the cooling tower as shown. On the options bar, verify that diameter is set to 3 inches and click the Home tab, and from the Plumbing and Piping panel, click Pipe Accessory. Then, click the Change Element Type drop-down, and under Ball Valve 2 to 6 inch bypass, select 3 inch. Then, click the center of the pipe to place the valve, and press Escape twice. Then, select the valve and click the top Rotate control to rotate the valve to a horizontal position. Then, press Escape, and let's place shutoff valves. On the Home tab, from the Plumbing and Piping panel, click Pipe Accessory. Then, click the Change Element Type drop-down, and from under Ball Valve 2 to 6 inch, select 4 inches. Then, click the midpoint of the supply pipe to the cooling tower to place the valve. Then, change element type to Ball Valve 2 to 6 inch bypass 4 inch, and place one on the return pipe to the cooling tower parallel to the previously placed valve. Then, click Modify and rotate both valves by clicking the top Rotate control to the left of each valve as shown. Next, let's add valves to facilitate a dual mode system. We will modify valves to bypass the cooling tower. First, select the small piece of pipe above the bypass valve and click Element Properties. In the Instance Properties dialog, under Mechanical, verify that Flow is set to 0 GPM and click OK. Clear the selection and understand that currently the system is designed to run in cooling mode. You will add valves to the cooling tower to enable the system to alternately run in heating mode. In heating mode, you want to shut off the flow of water into the cooling tower. You'll bypass the cooling tower with hot water coming from the boiler. Select the bypass valve, and from the Change Element Type drop-down, under Ball Valve 2 to 6 inch, select 3 inches. This valve allows the water to flow through it. Select the top regular valve, and from the Change Element Type drop-down, under 2 to 6 inch bypass, select 4 inches. Now, the flow going into the cooling tower is 0 GPM, and the flow traveling through the bypass section of pipe is 125 GPM. Close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will verify automatically calculated pipe size and flow parameters. Initially, you will use the pipe color scheme legend as a color-coded reference to view the flow within the pipes and the sizing. The color-coded display allows you to quickly see differing sizes and flow of piping. You will then use a combination of friction and velocity to size the pipes appropriately. Click the menu browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 06. Let's display the pipe color scheme legend. Zoom in to the shorter wing of the building and click the Analyze tab, and from the Color Schemes panel, click Pipe Legend. Then place the color scheme legend in the area to the right of the piping system as shown. In the Choose Color Scheme dialog, select Pipe Color Fill Flow and click OK. This option displays the pipes in colors based on flow values. Let's display the color fill based on pipe size. Select the color scheme legend and click Edit Scheme. In the Edit Color Scheme dialog, under Schemes, select Pipe Color Fill Size and click OK. This display will help you size the pipe using friction and velocity sizing methods. Clear the selection. Zoom in to the section of pipe connecting the boiler to the parallel base mounted pumps. Then move the cursor over the pipe between the primary and secondary base mounted pumps and press Tab 3 times so that the status bar indicates that you've highlighted a branch in a pipe network up to a piece of equipment, and click to select the branch. Then click Duct or Pipe Sizing. It's important to note here that the Pipe Sizing dialog displays the sizing settings that were last used. It does not report the sizing settings of the selected pipe segment or pipe run. Under Sizing Method, select Friction and change the number value to 2.25. Then select End, and for velocity, enter 5. Then under Constraints, for branch sizing, select larger of connector uncalculated and click OK. When you do, the piping increases in diameter based on the specified friction and velocity values. Clear the selection and note here that errors may occur while you are attempting to create pipe geometry as a result of converting a layout or during sizing. The most common cause of these errors is that there is insufficient space to create the pipe, or offset elevations are incorrect. Either relocate the system components, or select a different layout solution, or manually modify the pipe. Remember to always check pipe connectivity after modification. Close the file without saving it, as the next lesson will provide its own training file, and that concludes this lesson. In this lesson, you will use the System Inspector to inspect the Level 3 hydronic piping system. The System Inspector lets you inspect each piping system for flow, pressure, and pressure loss by placing the cursor over a pipe or mechanical equipment that you assigned to the system. Using the System Inspector, you can easily detect problem areas in your design and resolve them immediately. Click the menu Browser and select Open, and from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 07. Let's inspect the system. In the project browser, under HVAC Design 3D Views, double-click 3D HVAC Building. Then zoom in and select the section of the return piping, which is magenta color, between the two water source heat pumps on the upper level. Then, from the Analysis panel, click System Inspector. Then, from the System Inspector panel, click Inspect. When you do, arrows display on the pipe, indicating the flow direction for both the main and the branches in the pipe system. The critical flow, indicated by red arrows, is in the main line going to the boiler. Now place the cursor over the same section of return piping. When you do, an inspection flag reports the section number, flow, and pressure information, including pressure loss. This information helps you modify the system design as required. It is good to note here that to use the System Inspector to inspect flow and pressure inside pipe, the selected system components and pipe must be logically and physically connected. The pipe and the system components must be connected to a system, which is a logical connection, and a system must contain pipe, which is the physical connection. Next, let's modify fluid temperature. Place the cursor over the section of pipe between the two WSHPs on the lower level as shown. Note that the flow is 80 GPM, the static pressure is 7.67 psi, and the pressure loss is 1.89 psi. On the System Inspector panel, click Properties. In the Instance Properties dialog, for fluid temperature, select 90 degrees and click OK. Then inspect section 6 again, and notice now that the static pressure is 7.65 psi and the pressure loss is 1.88 psi. Click Finish. Then close the file without saving it, as the next lesson will provide its own training file. And that concludes this lesson. In this lesson, you will use the Check Pipe Systems tool to quickly check connections for all systems throughout your project, targeting those systems that need attention. Click the menu browser and select Open. And from the Training Files Imperial Mechanical Systems folder, open the file RME MEP Piping 08. Revit MEP uses both the pipe geometry and the system to perform calculations such as flow and pressure and to size pipe. Because both the logical and physical connections play a vital role in the overall system's design, you need to validate them. In the project browser, under HVAC Design Floor Plans, double-click Level 3 HVAC Plan Design. From the Analyze tab, Check Systems panel, click Check Pipe Systems. When you do, Revit MEP checks both the logical and physical connections of each piping system throughout the project. Warnings display. Notice that these warnings indicate that the default systems are not empty. The Check Systems warnings contain a system type and a description. These warnings can refer to both physical connection issues, such as a disconnected or problematic pipe, or logical connection issues, such as an improperly assigned system. Remember that after you create pipe to physically connect the system, the pipe is associated with that system. Pipe geometry is used for system flow and pressure calculations and for pipe sizing. Note that only physical connections associated with an unassigned system are checked. Pipe that is associated with a default system, which means located in the unassigned folder, is not checked. The most common Check Systems warning is Default System is not empty. As you learned when placing components, all system components must be assigned to a system after they are placed. If you place components without assigning them to a system, Revit MEP creates a default system and assigns them to it in order to perform system calculations. The default system is placed in the unassigned folder until you select the system components and create a system for them, thus assigning the components to a system. Note that a system component may be listed in both its assigned system and in the unassigned folder. This occurs when the assigned system component can be connected to multiple systems, which means it contains different system connectors, and you have not yet assigned the component to the other systems. For example, let's say you assigned a water source heat pump to a supply hydronic system, but the same component has a sanitary system connector that you have not yet assigned to a system. In that case, in the system browser, the water source heat pump is listed in the assigned system and assigned to the default hydronic sanitary system in the unassigned folder. Close the warning dialog, and in the system browser, right-click the title bar and click View, and verify that Systems and Piping are selected. Then, in the project browser, under HVAC Design Floor Plans, double-click Level 1 HVAC Plan Design. Then, in the system browser, expand the hydronic supply folder and notice that the condensing boiler 500 MBH is listed. Expand that and notice that CHWS is listed under it. Right-click CHWS and click Show. In the Show Elements in View dialog, click Close. The red dashed lines represent the logical connection. Using the same methods, expand the Unassigned folder and confirm Unassigned System Components. Then, click the View tab, and from the Windows panel, click the Switch Windows drop-down and select Level 3 HVAC Plan Design. Then, in the System browser, right-click Hydronic Return and select Expand All. Then, right-click CHWR and click Select to confirm this system and the assigned system components. By doing so, you have confirmed and validated both unassigned and assigned system components and their systems. Close the file without saving changes, as the next lesson will provide its own training file, and that concludes this lesson.